Today we are going to solve 2125 lead code problem, number of laser beams in a bank. Let's read the problem. Anti-theft security devices are activated in a bank. You are given 0 index binary string array bank representing the floor plan of the bank, which is m cross n. So if there are multiple floors, so that's why m cross n, and bank I represent the ith row. So that is the ith floor consisting of zeros and 1. It will be 0 means cell is empty, so each row each floor has some cells. 0 means empty and 1 means like some cell has a security device, and there is a one laser beam between any two security devices, and they are saying like between two security devices there will be one laser beam, but there is two condition in that. Condition 1 is two devices are located on two different rows r1 and r2, where r1 should be lesser than the r2. So see, this is r1, let's say this is r2, this is r3. So r1 is lesser than r3, that's why there is a laser beam. But the another condition is for each row I, which I is let's say greater than r1 but lesser than r2, there are no security devices in that ith row. So if there is a no security device here, then only I can say like this r1 and r3 there is a one laser beam. If there will be one here in r2, so then laser beam will be between r1 and r2, because there is no other security device in between these two rows. So that's the whole idea. Now the return the total number of laser beams in the bank. So if you can see, like row 1 has 3 laser beams, row 2 has 0, row 3 has 2. So every pair is, because the condition is like if r1 is lesser than r3, yeah true, so there will be one laser beam here. This is also in r3, this is in r1. So because again r1 is lesser than r3, that's why laser beam, and there is a no other security devices in between these two rows. There is no, that's a empty. So that's why the laser beam between will be between these two and this security devices. And we need to find all the possible laser beams, and also it says like laser beams are independent, so one beam does not interfere another nor join with the another, so we have to count it independently. So for this one let's say 2, for this again it's 2, for this again it's a 2. Now we r1 is, this is r4. Why there is a no laser beam between r1 and r4? The reason being there is a I which is greater than r1 but lesser than r4, and it has a security devices, so that laser beam will not be between this r1 and r4. Because of the second condition they will be not, but with r3 and 4 there will be laser beam, because if you go with the condition r3 is lesser than r4, and the second condition is there is a no any row in between these two I where the security device has been installed. Okay, and as they are not overlapping each other, there is a no such case, all are independent. So again 2 laser beam here. So total number of laser beam, how much it will be? 6 plus 2, which is 8. So let's see how we'll solve this problem. What we can do, basically let's copy the input once again. So the idea is, it looks like m cross n kind of thing, like you have to just find the number of ones, and this, because 3 into 2 is 6, now plus 2 into 1, so something like that, right, in the pairwise. So in the first one you counted 3, second row it was 0, third row it was number of ones is 2, and the fourth row number of ones was 1. So basically you will do first multiplication, which is 3 into 2, which is 6, and then there was 2 plus 2 into 1, which is equals to 8. So you need to find like the fun, you have to count the 1 and then found the next row which is having 1. So here in this row there is a no 1, so we need to go to this one. Here we found at least one row, at least one 1, so we can make that m cross n multiplication and save it into result. Now we need to find the another laser beam between from this row to the next row which is having at least 1 1. Okay, so how will be coding this out? Like will be calculating like this only. 3, we'll calculate the first number count, and then we'll do multiplication. We need to do multiplication something like this, because we need to filter it out 0 first. So let's say we filter it out something like this, then the output should be like something like 3 into 2 and 2 into 1, and in between you just think of it as not a comma operator but a plus, right? So the best way to do it is this: in a Python we can use a zip. Zip is like, let's say you have, if you are zipping this with this comma, let's say 2 3 1, what the output of the zip will be like, it takes the first element of these two and put it together and make it in a tuple. So it will become like something like 3 comma 2, then next will be become 2 comma 3, and the last will become 1 comma 1. Okay, so in this case how we will be doing, like, so it will become like this, is like, will, let's say this 3 2 1 will, next array will be from 1. So how it will be like, it will become will make from 3 to 2, and then 2, like, let's say this is now my new array without 0. So we'll do a zip of something like this: zip of array, let's say till the last value, comma array of starting with 1. Now see what it will become. So it will become something like this: zip of 3 comma 2 comma 2 comma 1, which is, and if we do then the tuple will becomes 3 comma 2 comma 2 comma 1. Now we can simply multiply these two values, a and b. So yeah, so we'll use this idea to code it out. So let's do the coding. Let's say number of beam interactions is like counting the number of ones in each row. We'll do here. So we'll iterate on this bank list, and if element is if there is a 1 in that element, what we'll do, we'll just count the number of ones in that. Okay, okay, we got it. Now what we'll do, we'll, as we said, like, we'll take the zip and create the sum. So sum, what I'm going to do, let's see. First we'll do like, we got the number of beam interaction. Now this is like ignoring the zeros, it's kind of filtering out the zeros, because we are first checking if there is a 1, then only we are counting it. Okay, so now what we can do is, we'll do the zip as we said, like beam interactions till the -1 comma beam interactions 1. So we got the zip, and then we will iterate on this a comma b, and we'll do the multiplication a into b, and this will be returning. Okay, so hopefully this is right. Like for a comma b in zip beam interactions, let's copy this, sometimes I misspell. So yeah, it becomes till -1, and then 1 is from starting from the second element. Right, let's run it. Yeah, it's working. Let's submit this. Cool, it worked. And yeah, time complexity wise it's also good. 85% it is beating, so not bad. Thank you everyone.